So to begin with, we're going to calculate the absolute uncertainties from repeated measurements. So we've got a list here of measurements for acceleration of free fall, and I need to look through and see that 13.63 is an anomaly, so I'm going to ignore it. And then what I now need to do is calculate what's my mean value. So I will add up the other 5 and divide it by 5, and then that comes out on my calculator as 9.834. And because all of the accelerations I've used to calculate the mean are only to 2 decimal places, I'm going to need to drop my mean down to 2 decimal places, so rounding down to 9.83 meters per second squared. Next, we've got to find the absolute uncertainty, so I need to see what's the range of my values. So there's my smallest and my largest, 9.63 and 10.12. So to calculate the range, I need to find out what the difference between those two is, and then if I take that and divide it by 2, that will give me the absolute uncertainty in my measurements. So my calculator is saying 0.245, and again, because all my accelerations are to 2 decimal places, this time I need to round up to 2 decimal places to give my absolute uncertainty of 0.25 meters per second squared. So my acceleration then is 9.83 plus or minus 0.25 meters per second squared. Next, we're going to calculate the percentage uncertainty from the absolute uncertainties. So we've got my 9.83 plus or minus 0.25 meters per second squared, and to get the percentage I need to know what's the absolute uncertainty as a percentage of the mean. So 0.25 divided by 9.83 multiplied by 100 to turn it into a percentage, and that gives me 2.5%. Now we want to be able to calculate the percentage difference of a measured value and an accepted value. So a measured value is 9.83, the accepted value is 9.81, so I need to know what's the difference between those two, and I want to know that as a percentage of the accepted value, so I divide by 9.81. Multiply that by 100 again because it's a percentage, and then that comes out as being 0.20%.